Your brain at 68 is not declining. It's not deteriorating. It's not slowly dying. It's doing something completely different. And what science has discovered in the last decade will change everything you think you know about aging. This is the science record. And today, we're exploring what really happens to your brain as you age. Let's start with the myth. The one everyone believes. The one that's been repeated so many times, it's become accepted as fact. The myth goes like this. Your brain peaks in your 20s. After that, it's all downhill. Neurons die, connections weaken, memory fades, processing speed slows. By the time you're 60 or 70, your brain is a shadow of what it once was. Except that's not what the science shows. Not even close. Yes, some things change as your brain ages. But the story is far more complex and far more interesting than simple decline. Your aging brain isn't broken. It's adapted. It's specialized. And in many ways, it's better than it's ever been. Let me show you what I mean. First, let's talk about what actually happens physically to your brain as you age. Your brain reaches its maximum size around age 25. After that, it does shrink slightly, about 5% per decade after age 40. By age 70, the average brain has lost about 10 to 15% of its volume. That sounds bad. But here's what's actually happening. You're not losing neurons at the rate we once thought. The old idea that you lose thousands of brain cells every day? That's been debunked. What you're actually losing is mostly white matter. White matter is the insulation around nerve fibers, the myelin sheaths that help signals travel faster between brain regions. Some of that insulation degrades over time, which does slow down processing speed. You're also losing some synapses, the connections between neurons. Your brain had about 100 trillion synapses at age 20. By age 70, you might have 10 to 15% fewer. But here's the critical part. Your brain doesn't need all those synapses. In fact, having fewer might actually be better. Think of it this way. A young brain is like a dense forest with paths going everywhere. It's exploring, it's learning, it's making connections between everything and everything else. That's useful when you're young and everything is new. An older brain is like a well-maintained park with clear, efficient pathways. It's pruned away the connections that weren't useful. It's strengthened the ones that matter. It knows where it's going. This is called synaptic pruning, and it's not a bug. It's a feature. Your older brain has spent decades learning what information is important and what isn't. It's built efficient networks for the tasks you do regularly. It's eliminated the noise. And this leads to something remarkable, something researchers call crystallized intelligence. There are two types of intelligence, fluid intelligence and crystallized intelligence. Fluid intelligence is your ability to solve new problems, think abstractly, and process information quickly. It's what IQ tests mostly measure. And yes, fluid intelligence does peak in your 20s and gradually declines after that. But crystallized intelligence is different. It's your accumulated knowledge, your vocabulary, your ability to use experience and pattern recognition to solve problems. And crystallized intelligence doesn't decline. It increases, well into your 60s and 70s. This is why older people are often better at complex decision-making, even if they're slower at mental arithmetic. They're not processing every detail from scratch. They're recognizing patterns they've seen before. They're applying wisdom. Studies have shown that older adults are better at seeing the big picture rather than getting lost in details, making decisions that consider long-term consequences, regulating emotions and maintaining psychological well-being, understanding social dynamics and reading people, solving problems in their areas of expertise. A 25-year-old might solve a novel puzzle faster, but a 65-year-old will make a better strategic decision, give better advice, and see connections the younger person misses. Your brain isn't declining, it's specializing. Now let's talk about neuroplasticity. This is where the science gets really exciting. For most of the 20th century, scientists believed that neuroplasticity, the brain's ability to form new connections and even new neurons, stopped in childhood. Once you were an adult, your brain was fixed, set in stone. That turned out to be completely wrong. In the 1990s, researchers discovered neurogenesis, the birth of new neurons happening in adult brains. Specifically in the hippocampus, the region responsible for learning and memory. And it doesn't stop at 30 or 40 or 50. Healthy 70-year-olds are still generating new neurons. Not as many as a child, but they're still there. Your brain is still capable of growth. Even more importantly, your brain continues to form new synaptic connections throughout your entire life. Every time you learn something new, every time you practice a skill, every time you have a novel experience, your brain physically changes. This has profound implications. It means your brain at 60 or 70 is not locked into decline. It's still adaptable, still capable of learning, still capable of change. Studies have shown that older adults who learn new skills, whether it's a language, a musical instrument, or a complex game, show measurable increases in brain volume and connectivity. Their brains physically grow in response to the challenge. The key is novelty and challenge. Your brain needs to be pushed. It needs new experiences, new problems, new learning. A 70-year-old who does crossword puzzles every day isn't challenging their brain much. They're using the same neural pathways over and over. But a 70-year-old who takes up painting, or learns to code, or studies a new language, that brain is building new connections, strengthening existing ones, maintaining plasticity. Use it or lose it isn't just a saying. It's neuroscience. Now let's address the elephant in the room: memory. Yes, memory does change as you age, but not in the way most people think. Working memory, your ability to hold and manipulate information in your mind for a few seconds, does decline slightly. This is why older adults might have more trouble remembering a phone number long enough to dial it, or keeping track of multiple tasks at once. Episodic memory, your memory for specific events and experiences, also becomes less reliable. You might forget where you parked your car or what you had for breakfast yesterday. But here's what doesn't decline: semantic memory, your memory for facts, concepts, and general knowledge. An older brain remembers vocabulary, historical facts, how to do familiar tasks, just as well or better than a younger brain. And procedural memory, your memory for skills and habits, remains largely intact. A 70-year-old who learned to ride a bike at age 10 can still ride a bike. The memory problems that do occur are often not about storage, but about retrieval. The information is in there. Your brain just has more information to search through. It's like trying to find a specific book in a library with 70 years worth of books versus a library with 25 years worth. This is why older adults often remember things better when given a cue or context. The memory isn't gone. It just needs a reminder of where to look. And here's something fascinating. Older adults are actually better at filtering out irrelevant information. A young brain tries to encode everything. An older brain is more selective. It focuses on what matters. This is why older people often seem to ignore distractions that would derail a younger person. Their brains have learned what's worth paying attention to. So what actually causes cognitive decline when it happens? Because let's be clear, not all aging brains stay healthy. Some do experience significant decline. Dementia affects about 10% of people over 65 and nearly 30% of people over 85. But here's the critical point. That's not normal aging, that's disease. Alzheimer's disease, vascular dementia, Lewy body dementia, these are pathological conditions. They involve specific biological processes: amyloid plaques, tau tangles, reduced blood flow, abnormal protein deposits. Normal aging does not cause dementia. A healthy 80-year-old brain is not on an inevitable path to Alzheimer's. The two are separate. What does contribute to cognitive decline in normal aging? Several things. Chronic inflammation. As you age, your immune system becomes less efficient and more prone to low-level chronic inflammation. This inflammation can damage neurons and interfere with synaptic function. Oxidative stress. Your cells produce reactive oxygen species as a byproduct of metabolism. Over time, these can damage cellular components, including in the brain. Your body's antioxidant defenses weaken with age, allowing more damage to accumulate. Reduced blood flow. Your cardiovascular system becomes less efficient. Less blood reaches the brain. Neurons get less oxygen and glucose. This affects their function. Hormonal changes. Declining levels of certain hormones, particularly estrogen in women after menopause, affect brain function. Estrogen has neuroprotective effects, and its loss can contribute to cognitive changes. But here's the good news. All of these are modifiable. They're not inevitable. Exercise increases blood flow to the brain. It reduces inflammation. It promotes the release of brain-derived neurotrophic factor, a protein that supports neuron growth and survival. Studies show that older adults who exercise regularly have larger hippocampal volumes and better memory than sedentary peers. Diet matters. The Mediterranean diet, rich in omega-3 fatty acids, antioxidants, and anti-inflammatory compounds, is associated with better cognitive function and lower dementia risk. Sleep is critical. During deep sleep, your brain clears out metabolic waste products, including amyloid proteins that can form plaques. Chronic sleep deprivation accelerates cognitive decline. Social engagement protects the brain. Meaningful social interactions, maintaining relationships, being part of a community, all of these are associated with better cognitive outcomes. Mental stimulation, as we discussed, maintains plasticity and builds cognitive reserve. And managing cardiovascular risk factors, controlling blood pressure, managing diabetes, avoiding smoking, all of these protect brain health. Your brain's aging trajectory is not fixed. It's influenced by how you live. Let me give you some perspective with numbers. The average 70-year-old performs about 10% slower on processing speed tests than the average 25-year-old. But they perform just as well or better on vocabulary tests, general knowledge tests, and complex reasoning tasks in familiar domains. A healthy 80-year-old brain has about 85 to 90% of the volume of a 25-year-old brain. But that remaining brain is more efficient, more specialized, and in many ways more capable. Studies of SuperAgers, people in their 80s and 90s with cognitive abilities comparable to people 20 to 30 years younger, show that their brains have maintained cortical thickness, particularly in regions involved in attention and memory. They haven't avoided aging. They've aged successfully. And here's perhaps the most important finding. Life satisfaction and emotional well-being actually increase with age. Older adults report greater happiness, less stress, better emotional regulation, and more positive social relationships than younger adults. Your brain at 70 is not a broken version of your brain at 25. It's a different brain, adapted for different strengths, optimized for different tasks. You've traded some processing speed for wisdom, some mental flexibility for expertise, some raw computational power for pattern recognition and judgment. And if you take care of it, if you challenge it, if you keep learning and engaging and moving, your brain can remain sharp and capable well into your 80s and beyond. The decline narrative is wrong. Your aging brain is not dying. It's evolving. If you found this fascinating, subscribe to the Science Record. Next week, we're exploring a darker chapter in medical history: the doctor who proved hand-washing saves lives, and the medical establishment that destroyed him for it. Thanks for watching. And remember, your brain at any age is capable of remarkable things. Don't let anyone tell you otherwise. This is the Science Record. See you next week.